Good morning, madam. I'm Li Chia. We are from Group 3. This project report details the development and implementation of a part recognition and counting system. It provides practical experience in designing a pattern recognition system using knowledge and tools. The goals were to create a system that takes an image as input, accurately classify a component, assign part number, return stock number, and count the component precisely. For objectives is to design a system that could analyze image and recognize each of the different components to which they belong. Approach is we explore the application of counting algorithm and perform the annotation using YOLO V8. Significant is we have a user-friendly interface that can facilitate image uploading, processing, and displaying the part that are identified.
Hi, I'm Avinash Murali, and I'll now be talking about the part recognition. Firstly, the labels of the four objects that we have taken the pictures of are defined under class name variable. Next, the YOLO V8 model is imported to detect and count the parts. YOLO V8 stands for you only look once. Next, for loop is used to iterate every image of the object class to detect which part of the utilization of YOLO V8. Lastly, the outputs for the parts and its amount are shown. For the next slide. All right, image preprocessing. Most of the images are in JPG and some are in JPEG format. Some of them are in HEIC. So those which are in HEIC is now converted to JPG to ensure the consistency of all file formats. And then the images are converted into RGB, red, green, blue formats, and they are resized to 128 times 128 pixels. Yeah, that's all from me. Thank you.
So this is the feature abstraction of our project. So we need to reduce the dimensionality of the data to 20 principal components. And the number of the components can be adjusted based on how much variance we want to retain in the data. Then these steps also calculates the principal components and learns how to project the data. And it also shows that we project the original data onto the 20 principal component. So this is the classification model that we use for our project. The first one is scan and it classifies the symbol by finding the k nearest neighbors in the feature space. The next one is SVM, and it classifies it by looking for the hyperplane that best divides the various classes and classify the image according to the side of the hyperplane where the feature vector lies. The last one is random forest classifiers, and it builds a large numbers of decision trees and produce the class mode for classification because random forest average many decision trees and it can prevent overfitting and is ideally suited for handling huge datasets with high complexity. So this is the result of our model and we provide a classification report of the performance of each classification model. The report includes precision, recall, F1 score, and support. So we use the YOLO to count the algorithm and do the annotation process. And YOLO is a powerful deep learning model specifically designed for real-time object detection and classification. It processes the entire image with a single forward pass predicting bounding boxes and class probabilities simultaneously. It is suitable for tasks where multiple parts need to be detected and classified with an image. This is all for my part. Thank you.
Hi, my name is Wan Hao and I'm in charge of the project demonstration. So when the Tinker interface is run, the window will jump up and the user can upload the image from the File Explorer. So sometimes the image will be predicted wrongly, although the image is classified. So for example, the gray block is misclassified and wrongly labeled as circle. These are the some success example for the transparent block, circle, and the black block. So this is the output of the code. So the output will label what are the parts of the components, such as the list of the index and quantity of the parts. So the number in the bracket means one means the batch size, which that the one image at a time is being processed in the image. And 3 is the number of the color channels. And 2, 5, 6, and 192 is the width and the height of the photos. Thank you.
For conclusion, the Advanced Part Recognition System project aims to classify image into categories such as black block, circle, gray block, and transparent block. Using high-resolution image pre-processed to 128 times 128 pixel and grayscale, the dataset was split 60% for training and 40% for testing. Future extraction with BCA retained essential feature. SVM show high precision recall and F1 score for the black block class. While KNN with BCA achieved 97 accuracy, excelling for gray and transparent block. YOLO V8 enhanced real-time object detection, improving practical applicability.